Good morning. I hope you're all doing really well today. It's been pouring rain here for a couple of days and everything is saturated. It's a bog outside. So James, no, I wasn't installing updates right before going live. Uh, there is a funny thing though. I was sitting here with the time almost ready to go. I had all the screens open. I've got Eagle in front of me. I've got an overhead camera so I can show you a prototype. And I was looking at the time and it was 1 minute to go live time, and I thought, oh, that's right, I need to open YouTube Studio. I had totally forgotten to do it. But before I get too much into anything else, time for a very quick history lesson, something I just discovered. I live to the east of Melbourne and I grew up on Mount Dandenong, which pretty much anybody that lives in Melbourne should know. And something I only just discovered is that the original name for the Dandenong Ranges was Koranharagwal. I think that's how you pronounce it. And the origin of the name Dandenong was originally the local Aboriginal word Danginon, which means high or lofty, and that was what they called the peak of Mount Dandenong. And then over time, the spelling and the pronunciation changed and it became D instead of G, and it got an E instead of a Y, so it became Dandenong. But Dandenong is based on the local Aboriginal word Danginong, which is high or lofty, which is very appropriate. So today I'm going to start by showing you the EtherUNO prototype, and I just assembled the latest PCB for this last night. I've got it sitting on my bench just here. In fact, you can see it on the main camera out of focus kind of in the background. I've got an overhead camera so I can show it to you. In fact, let's jump straight to that. And is this going to work? Let's find out. Alright, yes, I've got a kind of dodgy setup at the moment. I've been waiting now for 5 months, I think it is, for 2 HDMI capture devices that I ordered. And unfortunately I ordered them right at the start of the whole COVID isolation sort of period, and they still haven't arrived. So at the moment I'm running on a CamLink adapter on my main camera, which was very, very kindly given to me by a viewer, and I've got a blank on who it was. I'm really sorry, but thank you. And so I'm running a Game Capture HD for this. So what you can see at the top, this is the previous prototype of the EtherUNO, and this is when my general plan had been to go for a WISNet W6100. So this was before my concept. Basically, this was while I was still trying to fulfill 2 mutually exclusive objectives and mash them into one board, and it really didn't work out as I expected. So this is the, it's an ATmega 328, so same as an Arduino Uno, but it has on it the WISNet 6100, which is I think it's the most up-to-date of the WISNet chips with IPv6 support. And also I dropped the ATmega 16U2, replaced it with the CP2102 USB to serial adapter, and it's got USB-C on it, as you can see. And that actually works. Like if I plug that in, it fully functions. But it had a couple of issues. Firstly, you can't actually use the W6100 in IPv6 mode with the ATmega 328 because the 328 just doesn't have enough RAM. And so there is actually no point going to a 6100 on that board. It's a total waste. And so once I started thinking about that, I realized that what I should be doing is doing a version with the 6100 and a bigger processor, which is going to become the EtherBear. But I'm not going to talk about that right now, because I'm going to talk about the EtherUNO and how that is sort of shaping up. So the latest iteration of the EtherUNO prototype, which is what you can see down the bottom here, is kind of going back to the original concept of what the Ether 10 was supposed to be. It was oh, hang on. Is my audio being too low? let's see. I can turn the audio level up a little bit if people are saying that it's okay. Oh, and AB. Yes, okay. I was waiting for you before I started. Audio is fine to me. Okay. Very good. It's probably getting a bit quiet as I slide over to the workbench. I'll try to speak up when I'm sitting over there pointing at the board. It's a little bit of foreshortening. The distance when I'm sitting at that bench is a bit back from the computer. So as I was trying to revise the whole concept of what the EtherUNO was supposed to be, things became a lot clearer to me because I realized that it really needed to be the original concept of the Ether10, which is a drop-in replacement for an Arduino Uno and an Ethernet shield combined together, smushed onto a single PCB. So I wanted total functional equivalence and software compatibility and all of that sort of thing. You shouldn't need to install a custom board profile, shouldn't need a custom library. You should be able to plug it in, use it out of the Arduino IDE out of the box. And once that idea was fixed in my head, the design of the EtherUNO became a lot clearer to me. And so what you see at the bottom here is going back to that original concept. I wonder if I can get some zoom on this. The focus on this overhead camera is not great when it zooms in. Sometimes it can freak out a little bit. Yeah, that's about pushing it. That's about as far as I can zoom it in. So, alright, so the configuration of this one is ATmega 328 processor, so UNO compatible. WISNet W5500 instead of the 6100. The 5500 is supported now in the official Arduino Ethernet library, so it should work out of the box, and that is what's on official devices. And I've also rolled back USB serial. Now on this version, this is the CP2102N with USB-C connector on it, and on this one I've rolled back to an ATmega 16U2, just like an UNO, once again with the USB-C connector, which is why you can see it's got an ICSP header. It's got the crystal is back again, that disappeared on this version. So functionally, this board really returns to the original concept. It's the UNO with a modern version of the Ethernet shield smushed together onto a single PCB. And that really is making things much clearer for me in terms of how it's coming together. And you can still see it's still got power over Ethernet support. It's got those headers along there. In fact, I can demonstrate that. I'll unplug USB, so it's died. And what will I do? Okay, I'll unplug the other end of the Ethernet cable. And what I've got, I'll wave this around on the camera. So this is a power over Ethernet injector, and I can plug this into my bench supply. So I've got, what have I got it set to? 10 volts. So I can inject 10 volts down the USB cable, plug that into the switch at the other end, plug in Ethernet, and turn on the power supply. And if things work, which they are currently not, oh, I know why. Silly me. It's because I didn't put the jumpers on the PoE header. So I'll unplug that, stick the jumpers on here. That's the classic, did you turn it on or did you plug it in thing. So plug in Ethernet, and now we've got power over Ethernet running it. So that works as you would expect. But, oh, and also one other little hacky thing that you'll see is just on here, there is this HC49US style crystal, and I've patched that onto the PCB because compared to the previous design, well, with the Ether10, wherever it is, I've probably got one here somewhere, I had these HC49US style crystals for both the Ethernet interface and the main processor, and also for the 16U2. So it had 3 of these big crystals on it, And I ended up switching to these little surface mount crystals. You can see one of them is just there. There's another one up there. And there is meant to be one in that location. The problem is that I don't have any 25 megahertz crystals in this footprint. So I had to kind of hackily attach the crystal to the PCB. But that's not how it's meant to be. Once this goes into production, this big crystal won't be here. It'll be one that looks like this. And that's what the footprint is for on the PCB. So in fact you can see it on here. If we pull this up in Eagle, that's the footprint for it right there near the int connection. But I had to do a dodgy. Now, there is only one thing that is not working on this board at the moment. It's nothing important, it's just the Ethernet. You know, who cares about that? So, let me see what I got. Okay, as an example, let's switch to the desktop. And I'm going to have to... Nope, I'm going to have to Oh, I don't have USB plugged in. Of course. Alright, I'm just going to unplug that plug USB back in. Okay, so the device is now plugged back into my computer. We've got the connection back. Open this up. So at the moment it's failing to initialize the Ethernet chipset, and the chip itself is behaving in a slightly strange way. Even without anything plugged into it, it's reporting that it has got an active physical link, which is not right. And if I switch back to here, so you can see there's no Ethernet plugged into it, but the green LEDs down here are showing that it's got a 100 megabit link and the link is active, which is wrong unless it's some miraculous wireless connection. So there is something misbehaving with the WISNet chip at the moment, so that's what I need to look at today. I think it's pretty close to being okay. Now the thing is that SPI is actually working. So if I load this sketch onto it, what this sketch is doing is it's basically just reading the SD card, getting the info of what card is plugged in. Hang on, you can't see that. Back to the desktop. There. Alright, so this is the sketch that I'm loading. I'm just uploading it right now. And then in the console, what you can see, if it's not too ridiculously small, can we zoom? No, not without changing settings in the IDE. But what you can see here is the info coming off the SD card. It's told us it's FAT32, it's a 16 gig card, so it's reporting 14.8 gig usable. And I pulled this card out of my drone, so it's got some, you can see it's got DJI files on there, and it successfully read the list of files coming off it. So that means that SPI is working okay, and both the WISNet chipset and the SD card are on the same SPI connection, so it's just different chip select pins. So that means that it's probably very, very close to functioning. I just need to spend some time looking at why the WISNet chip is not responding, and then we should be all good to go. It's probably one of those things where I will spend hours and hours messing around with it, and then I'll discover that there is one tiny little thing and everything will be fine. Alright, now, oh, Simon Norton said, do I see PoE on the board? Yes, you do. Now, let me just say hi to Andy, who is in the background looking at comments to hopefully catch any and make sure that I don't miss any. Yeah, so it has power over Ethernet support, and it can do either. Well, the general approach with this board is to is to expose the connections for PoE and then give you options for how you want to implement it. And so what you can see down here, this header, it's got the connections coming in from the RJ45 connection, the RJ45 socket, and you can either just put jumpers straight across it and bridge the PoE pairs directly onto the onboard regulator, and then you can do something like feed 10 volts or 12 volts down the wire, and that means you don't need anything else in the circuit. It's just two jumpers, and it's really simple. But if you want to implement 802.3 AF or something like that, there is a module that plugs into this which implements the 1000 volt isolation, and it does the buck conversion from 48 volts down to 10 volts, and then feeds that 10 volts into the onboard regulator. And that means that if you want to work with a proper PoE switch, which outputs 48 volts nominal, then you can do that. Or if you just want to use like a little cable splitter like that one that I was just using and shove like 10 volts or 12 volts down the wire, it costs you a couple of dollars to get one of those, then you can do that too. So it gives you flexibility to handle it either way. Now, John Tamplin said, and no, it is not a dumb question at all. Any chance to increase RAM? Yes, but only by switching processors. And that is what I'm investigating with the EtherBear project. And in fact, I can show you some of that right now. I just need to find it. Projects. So before I really look at the EtherBear though, one thing, is there anything else I should wrap up? Okay, so the current status with the EtherUNO is that, apart from this glitch that I've got with the WizNet chip on this latest prototype, which I'm confident that I can fix. I just haven't had time to look at it since I assembled the PCB last night. That should be a direct drop-in replacement for an UNO plus an official Ethernet shield with full support out of the box from the Arduino IDE. And that should be just about ready to go. Hopefully there will be some silly little thing, maybe even a software issue, I don't know. The Arduino environment on my computer is a little bit messed up, so it's possible that I'm just not even using the right library or some silly thing like that, because I've been playing around in the past with customized versions of the Ethernet library, and when I was just compiling it, I might have even been calling the wrong library. I don't know. I will look at that and figure it out. So that should be ready to go. But to me, this is the EtherUNO is interesting in that it's a really convenient board, but it's not interesting in terms of being able to do new things that you couldn't do before. It's really it's taking what you could already do and making it really convenient, adding power over Ethernet and smushing it all down to make it small. So the interesting thing comes with other projects like the EtherBear, and I just need to find that. I've kind of put the EtherBear on hold at the moment because I wanted to get the do I want to load it? Yes, because I wanted to get the EtherUNO design fully squared away before I switch my brain back into a different mode and start looking at the EtherBear again. So this is the EtherBear on screen, and this has the WizNet W6100 on it, so it has the potential for IPv6 support if you enable that in the library. It's got a CP2102 as the USB to serial converter, USB-C once again. And the big difference is that over here, not quite fitting in this space yet because I need to do a bunch of shoving around, I ripped out the ATmega 328 and I put a 1284p on there instead. And this one is the 1284p is a really interesting processor. If you're wanting 8-bit AVR compatibility, then but you want as many resources as possible and you don't want to go for something like a 2560, which is the processor used on the Arduino Mega, which is a physically very big chip with a lot of pins and a lot of I/O. This is really cool because it's got a lot more flash memory, a lot more RAM, and it's got dual hardware UARTs, which means you can have hardware serial communication with something like a host via USB and hardware serial with some other device like a GPS unit or whatever it is that you want to talk to. So I really like the 1284p, and it's got enough memory on it that you can run FreeRTOS on it. So it's, as far as 8-bit processors go, it's actually surprisingly powerful. It's still limited to the same clock speed and all of those sorts of other limitations as the regular AVRs, the regular 8-bit AVRs, but it's a very cool processor. So for me personally, I think this EtherBear is going to be a very interesting board because it's got that much more capable processor on it. It's got the W6100, so we can do IPv6, and it has the CP2102N for USB to serial conversion, which is just nice. It's fast, and the circuit for it is very simple because you don't have to implement an entire little processor essentially, which you're doing with the 16U2 on the regular Arduino designs. So there's no crystal and it's missing a whole lot of other things. So this particular part of the circuit, like this area up here where it does the USB to serial conversion, that is so much simpler on this board than it is on the Arduino Uno or the Ether 10 or the 11 or any of those sorts of boards, which is nice. Okay, so oh, and Joel said, with these new boards, will there be the standard auto MAC address? Yeah, so there is a, where is it? Up here. This chip right here. If I can find that one. So it's the MCP24AA025E48, which is a MAC address ROM. And so for those who don't know what Joel is talking about here, on typical Arduino boards, when you set up the sketch, you have to define the MAC. Now, if I go back to here, here's a good example of it. So this is in the DHCP address printer example. You can see that it's defining a MAC address in here, but there are a couple of problems. One is that it means that if you deploy multiple devices, you have to change this value in the code and then compile it when you upload it to your little device. And that means you've got to keep track of it, and this was a real pain. So when I was setting up my home automation system originally, and originally I had Freetronics 2010s and Freetronics Ethernet shields in every light switch. And what I did was I had a spreadsheet which listed every light switch. In fact, it wasn't just light switches, it was all the devices in my house with their MAC addresses and what IP I'd assigned it, etc. Its physical location, a whole bunch of info. And then what I had to do was when I deployed a new device, I would have to come up with a new unique MAC address and then compile it, etc. for that. And it's a real pain. So what I ended up doing was putting that MAC address ROM on the Ether 10 at some point. The original Ether 10, the very first version, didn't have it, but then I added it a little way down the track. I think it was around 2012, maybe in the 2013 update. I added that MAC address ROM, and what that allows is for the sketch to load the MAC address out of the ROM on startup, which means that you can, in fact, I wonder if I've got an example of this. Let's see what I can find. Come on, you can open a menu. I'm still waiting for it to open the file menu. So what it allows you to do is run the exact same code on every device, and on startup what it does is read the MAC address out of the ROM and then use that when it connects to the network. And each ROM has a unique MAC address in it, so it means that all of your devices get unique addresses automatically, and you can run the same code on every device. Let's see what I can find here. Is there a... oh, where is it? This one, MAC address demo. I think this might be it. Is it going to open? There's some example code on the Freetronic site which shows how to read the MAC address out of that ROM. Oh, there we go. And so all you have to do is connect using I2C to the MAC address ROM, and you can see that it's got the address defined there, hex 50, and it's just got a placeholder which is going to be populated. And then what it can do is read the registers out of the ROM and stick them into the different octets of the MAC address. And then by this point, you've got your MAC address set in. So this is like, that's the bottom of the sketch. This is the whole thing. So what you need to do is just add this function into your program, stick it down the end somewhere, and then in setup, you use that to read the registers out of the ROM, you stick them into the MAC address, and then you can use it. So this is not a full example of connecting to Ethernet, this is just an example of reading that MAC address ROM to get the value. And then you can just paste that code into your own project, and then you never need to worry about doing this sort of silly thing in the future and statically assigning MAC addresses. Alright. Oh, here's an interesting question. So Dentistry's said, I do a lot of circuit design, mainly educational, but also home automation based. I want to do some compatible with some of your modules. Can I put Superhouse compatible on the PCBs? Sure. I'd be very happy if you did that. Yeah, I mean, I could go off onto chasing a squirrel here of trademark issues that Arduino have had in the past, but maybe that's not the best thing to talk about right now. But yeah, if you want to do that, that would be fine. And thanks for the link to your site. I'm going to check that out after the live stream. And oh, Johnny Bergdahl asked, any chance for TLS support? And the short answer is no. Basically because the 8-bit AVRs just don't have the grunt to do it, which is unfortunate, but yeah, you really need to do that. You really need to go for a processor, something like the ESP32. And I have a feeling that there might have been some attempt to do TLS on ESP8266, but I can't remember. Maybe someone in the chat can talk about that. So yeah, I can't remember specifically if anyone has achieved it. I think there might be a library called TinyTLS. I just don't remember. Daniel said, I don't know if you mentioned yet, with that board you can use both Ethernet and memory card simultaneously. Yes, that's correct, you can. In fact, one of the tests that we do at the factory for the Ether10 is put the, like there's a whole test procedure that involves a test jig that the board gets put into, and then it's exercised. And it has connections made through the DC jack, through the Ethernet connection, and through USB, plus there is an SD card that is put onto it. And part of the test procedure is to, a test sketch is loaded, and what the sketch does is exercise a whole bunch of I/O on it in collaboration with the test jig to make sure that all of the headers are working properly. But one thing that it also does is serve up a web page which provides a list of all of the files on the SD card. So part of the test procedure on the Ether10, and this is done on every single Ether10, it's not just like a spot check process, is to put an SD card into it and then load up a web page and view the list of files that are on the SD card. on the web page, and that is a way of verifying that communications is working and also that it's talking to the SD card. So it can do that simultaneously. So AB asked any rough price point at this stage. So it won't be any more than the current Ether 10, which is currently, I think, $59 Australian, and I'm hoping that it's going to be less. The reason that it could be less, if it is marginally less, is that the WISNet W5100, which is the chip that's currently on the Ether 10, is now so old that it's becoming hard to get, and I'm paying a premium for that just to be able to keep producing that design. So the existing Ether 10 design, and this is partly what really pushed me to doing something about revising this now, the current Ether 10 design is costing more to make than it should, simply because of using that old W5100 chip. So by switching from the 5100 to the 5500, it saves, I don't know, a couple of dollars on the bill of materials, which is a reasonably significant thing. So hopefully it will end up being less than the current Ether 10, but we'll see how that goes. Yeah, so James asked, do you see the EtherBear priced between EtherUNO and EtherMega? Yes, hopefully it will be a similar, my actual aim with this is to be able to price it at about the same as the EtherUNO, which sounds strange because it's a more powerful board, it's got more features, but the thing is that the actual cost of production should be very, very similar. So there are really three main differences in terms of the production cost. One is that it's going to use a CP2102N for the USB to serial instead of a 16U2. Now a CP2102N is cheaper than a 16U2. So there'll be, and also it doesn't need the crystal, doesn't need a couple of the other supporting parts. So it's going to save a little bit on the bill of materials there. The other thing is that the WISNet 6100 is approximately the same price as a 5500. There's a few cents difference in it. It's not like one is 50% more than the other. They are very, very similar in price. So price parity should be about right there. The ATmega 1284 is slightly more than the ATmega 328, but it's not really super dramatically more. So when you balance all of that out, the processor is going to cost slightly more, the USB to serial is going to cost slightly less, the Ethernet is going to cost about the same. I think the cost of producing the EtherBear is going to be somewhere in the same ballpark as the Ether 10 or the EtherUNO, which means that it can retail for about the same price. Now, the reason that, so that raises the question of why continue with the EtherUNO when the EtherBear can do more for the same price? And this is really the thing that was messing up my thinking about the design of this early on. So when I was trying to figure out what specs I wanted on the EtherUNO, and when I was doing things like switching out for the W6100 chipset, it took me a little while to understand the difference between the value of the features and the technical specs versus the value of ease of use and compatibility. So the two boards will be approximately the same price. One will be significantly more powerful than the other, but it will have the disadvantage that you'll need a custom board profile and you will need a custom Ethernet library. And that is a barrier that many people just won't want to cross. And that's really where I think the distinction comes in. The idea is that there'll be these two boards that you can choose from, and one of them you can just plug in and use out of the box. And that will be a really nice experience for people that just want to get started with the Arduino IDE. And the other one, you'll need to install the custom library and the custom board profile, and then it gives you access to IPv6 and all of the extra memory of the newer processor, well, bigger processor, etc. But many people won't want to take those extra steps to do that. So it's really addressing two different needs. So similar price point. And 50 Hertz wanted to know, how far off from production are you? Really, really close. So what I was hoping was that I would assemble this board and plug it in and everything would just work, and then I could sign it off and say, yes, this is it, let's go to production, in which case I could have these in stock in a matter of weeks. But and that may still be the case, but I need to figure out what's going on with the Ethernet initialization. So you can see that the green LEDs there are on, showing that it's got an Ethernet link, and there's nothing plugged into it. It may just be that there's a solder bridge or something on it, because I just assembled this one by hand. I used the pick and place machine to put most of the parts on, like all the basic passives and things were done on the pick and place machine, and then by hand I put on the unusual parts that I don't have loaded in the machine, and then I just ran it through the reflow oven. But I literally did this last night and got it assembled right before, just before I had to go inside for dinner, and I plugged it in and did some basic tests, and found that the SD card was working, and basic stuff was working, but Ethernet wasn't working, and that is as far as I've got with investigating it. So once I take the time to really experiment with that, hopefully today, and figure out what's going on, I might find that that one is ready to go to production, in which case it will be very soon indeed. And if not, if there is something wrong with the design, it's at the point now where this design is should be so close to final that anything that needs to be changed would just be like a minor tweak. Perhaps I've messed up one of the pins on the WizNet chip or something when I was rolling it back from the W6100 to the 5500. The pinouts are totally different, so I had to remap all of the pins and reroute that part of the PCB. I might have just made a mistake there. Joel asked, with the EtherUNO and EtherBear, is there going to be isolation for power from the 802 PoE to the USB? I normally just have one device plugged in, but I was helping the kids next door with their school projects. I had a couple die when plugged together. That is interesting. I'd like to know what it was that died. Was that on an Ether 10? Because the way the PoE works on the Ether 10 design, it shouldn't be possible for power to backfeed from PoE to USB, and I'll show you why. Let's have a look at the where are we? EtherUNO. I will pull this design up on screen in just a jiffy. So here we go. Desktop, where is it? Desktop view, that one. Alright, so this is the EtherUNO prototype, the version that's currently on the bench. And this basic principle is also what's used on the Ether 10. So if you're using an Ether 10, this should be the same thing that happens. So what you can see here is that there is the DC jack up here. This is where power comes in if you just plug something into the DC jack on the board. It comes in through a diode for a reverse polarity protection. And you can see that the output of the diode comes into the input of the 5-volt voltage regulator, which is right here. And then the output of the regulator goes to the 5-volt rail on the board. So when you plug power in from the external power supply, it comes in and just supplies 5 volts onto the board. And this is a linear regulator, so it doesn't care about problems with back power. So if you actually supply 5 volts from some other source onto the output of this regulator, it doesn't care. It's not like a lot of switch mode power supplies that will explode if you do that. And you can also see here that the output of this diode comes to V in. Now just down below here, I'll just skip over this bit because it's not particularly relevant. You can see here the 3.3 volt power supply comes off the 5 volt power supply. So it just takes the 5 volt rail, regulates it down to 3 volts, 3.3 volts. But let's ignore that for now because it's not really relevant to this question. So we've got power coming in from the DC jack, and it's got V in here. And you can see that V in comes down to this voltage divider, and it goes into this LM358, which essentially is acting as a switch. And you can see that USB power is coming in here. Now, USB 5 volts when you plug it into a host computer. So if you plug in to a host, you will get the data connection, but you'll also get 5 volts supplied from the host. And that comes down this USB VCC connection, and it goes into this FET, the FDM340P. And the source of the FET is connected to the 5 volt rail, but you can see the gate of the FET is controlled by this circuit in here. Now, this is actually kind of interesting, this whole thing. And it's a question that comes up a bit, people that want to know about connecting power to an Arduino at the same time as connecting it to USB. And this little circuit is what makes it possible. So what this is doing is acting as a switch, and it detects when there is power available from the V-in. Now remember, up here, V-in is going into the input of the voltage regulator, which then supplies the 5 volts. So if you plug in external power on here, what happens is this voltage divider provides a voltage onto this input here of the LM358, and this circuit acts as a switch and turns off this transistor, and that effectively blocks the, well, it's still got a body diode in there, but this effectively blocks the USB power getting through to 5 volts, and it prioritizes the DC input over USB power. So if you've got an Arduino plugged into USB, and it's also plugged into an external power supply through the DC jack, it will draw power from the DC jack. It won't draw it from USB. You'll still have the ground connection through USB, so you might have issues with like common ground loops and that sort of thing, but it won't draw any power from it. It'll just have ground and data connected to the host computer. So then if there is no power on V-in, this will allow power to pass through from USB to the 5 volt rail, and it will be powered directly off 5 volts. Alright, so the reason I went into explaining that is that you need that background to understand the next part, which is in relation to PoE. So if we have a look down here, this little block here represents the power over Ethernet header. And if we have a look up here, we can see that we've got V plus and V minus coming out of the RJ45 socket. So these are the power pins coming from the Ethernet connection, and they feed down to this header, and normally they don't go anywhere. If there's nothing connected on this header, those extra connections from the Ethernet just do absolutely nothing. They're not connected, they're totally isolated. So they should be safe in that regard. But if you bridge across them, say you put a jumper across pins 4 and 3, and you put another jumper across pins 2 and 1, so that they are bridged together. I'm going to hack around in the thing here, and I'll say yes, and then stick it across here. So effectively, this is what's happened. If you put those jumpers on, you are linking the V plus coming from the PoE connection through to V in. But remember that V in, if we look back at the other sheet, is coming in here. It's the input to the onboard voltage regulator, and it is isolated from USB VCC by this FET. And the result is that if you put those jumpers in place and you feed power, where are we? Wrong sheet, there we go. So if you put those jumpers in place, which I've just represented there with nets, then effectively what you are doing is connecting to the DC input, the DC jack, although you're doing it from behind the diode, but still, it's as if you've plugged into the DC jack. The only difference is that you're doing it at the other end of the Ethernet cable. So you should still have the same level of isolation between the PoE side of it and the USB side of it as you do with if you had USB and just plugging in directly into the DC jack. So hopefully that answers the question. Now the slight extension to that, I showed the simple case here, which is putting jumpers across those pins, and those are the, it's a bit hard to see when it's small, but those are the little jumpers that I put on just here. That is what bridges the Ethernet power through to the voltage regulator and the local power. Now instead of putting, let's get rid of these. If instead of putting jumpers onto those, you instead put a power over Ethernet module that supports 802.3 AF, the module itself also has its own internal isolation. So if you use something like a Silvertel module with the 1000 volt isolation, then you will still, effectively what you're getting out of the output of that module is 10 volts that feeds into the onboard regulator, but it is still isolated in the same way from USB. So, so the original question was about isolation between PoE and USB power, and for all the different scenarios that I can think of, I don't think that there is a way for that isolation to fail. Now there is still the common ground issue, so it's going to depend a little bit on how you are feeding the PoE in at the other end, but that is something that's external to this board, and I don't think there isn't a straightforward way around it. There are ways around that by isolating things in a different way, but that's a bit of an edge case. Alright. DIY in the Ghetto said, a question, Arduino's Ethernet shields with temperature sensors. When I scan for IP to see different IP address host names show all the same. Is there a way in Arduino to assign a new host name? I have multiple Arduinos and sensors in different rooms. I have no clue which is which. I know there is a way to change the host name in the shield, but no matter what I've tried, nothing works. Alright, so and then Mike came up with a suggestion for that, which is you can postfix your hash of your Mac in the host name you set in the Arduino DHCP client config. Yeah, so the host name, okay, so host name is a DNS concept. It's not really a low level. The networking stack it's got multiple layers, and I'm going to switch back. This is where I start explaining things and I wave my hands around and I don't really make a whole lot of sense. So I'm not really entirely sure I understand the question. When I assume that when you say host name, you're seeing that appear somewhere like in your router or some way that you can before I get into that, Steve Cody just said, with Ethernet power inside the reverse voltage protection diode, there is a chance that a miswired PoE crossover cable might do some damage. You're right, that is true. So one change that could be made to this design is to move the PoE injection to the outside of that reverse protection diode. There was a reason to not do that, and what was it? I can't remember. Well, another way to do it would just be to add another diode, because the problem is if you move it just to the outside of that diode and then you have something like a power supply plugged in, say you've got Ethernet plugged in with PoE and then you also plug in a DC power supply, then you've got a problem. I'm getting all sorts of video tearing going on here. Wonder what that is. And yeah, you get 0.6 volt drop over the protection diode. So the other way to do it would basically to make make a little diode OR gate. You have two diodes, one which is protecting from the DC jack, the other which is protecting from PoE. I'll have to think about that because it might be worth adding that extra diode to isolate the PoE input just to give that extra little bit of protection. NBN dropouts. Yeah, I don't know what's going on. No, I don't think it is because I'm seeing in OBS, I'm seeing local tearing on the video. It's having trouble doing the video encoding. Yeah. Let's try. No, okay. So back to the original question. So the whole thing about host names. With host names are labels that you temporarily assign to IP addresses. That's probably the simplest way of looking at it. It's like it's a human readable and machine readable way of assigning a label to make it easy to find a device, and the device's IP address could change but the label can stay the same because it just points to the new IP address through the domain name server. So I suspect I must be misunderstanding the question, but the way you assign host names in that situation, okay, anyway, I don't think I've got enough information on the question to give a sensible answer on that. Alright, so there were a couple of questions. Dodgy said, feeling a little scared that I understand what you're talking about. No, Dodgy, you understand more than you think. Dodgy is always down on himself. He always thinks that he doesn't know as much as he does. Okay, so Steve said a device has to interrogate a DNS server to translate a name to an IP address. Yes, that's correct. So it's a lookup service. And Mike said, I should have said the DHCP client identifier, which the router will use as a temporary host name. Ah, okay. That is a little different. It sounds like Mike has already answered that. So, all right, now, there was a comment here from Adam P about can it pixie boot? That is opening up a can of worms. The short answer is no, not in the strict sense, but then, do I open this? I should say, do I chase this particular squirrel? Now, there was a project that was done quite a few years ago. I'm just going to see if I can find it. There is an alternative bootloader. So this is a seemingly simple question with a complicated answer. And I'm going to see if I can find a reference for you that might help with this. Because there was a thing that a friend of mine over in New Zealand did many, many years ago. Where are we? Tutorials, I've got to find it. Please excuse me while I'm searching for things. How to upload a sketch to your Arduino via a network. Alright, so Philip Lindsay did some work on this many, many years ago. And I'm going to drop this URL. This tutorial is quite out of date, but if you're interested in this, it'll give you some things to investigate to look into this further. Okay, upload sketch via network. I'm going to stick that in the chat. Now this is a little tutorial that Philip wrote a few years ago, and what you can do is use TFTP boot and set up a server on your network that can push new sketches, or they can make, rather, it makes new sketches available so that devices on the network, like an Arduino on your network, can pull it down. And that way, it's kind of like what you would consider to be an over-the-air update, like an OTA update that you would do on a Wi-Fi device, but doing it over wired Ethernet. So the device connects to the TFTP server, it grabs the new sketch, downloads it, installs it on itself, and reboots, and then it's running the new sketch. And you can do that totally remotely, which means that you can have devices on your network and push the new sketch, just put it onto, basically you make it available on the TFTP server, and then the devices that are on your network will update from it. Now it's a fairly long tutorial, and it also depends on running a custom bootloader, because the bootloader that is on a standard Arduino excuse me, is intended to receive sketches over USB. And that means that if you want to, the short version is that out of the box, you can't do it with an Arduino. Oh, time to go for the trusty iced coffee. Okay, so you can't do it with either an Ether 10 or an Arduino with an Ethernet shield on it, because the bootloader just doesn't know how to handle it. It's got no mechanism for connecting out to a remote server, grabbing a new sketch, pulling it down, and installing it on itself. But there is a special bootloader that you can install, and that bootloader, rather than accepting updates over USB, although it still does that as well, accepts updates using TFTP. So I'm not an expert on that area. I have done, I've used TFTP in the past myself to do updates of firmware on different devices, like on OpenWRT routers, and I've done TFTP installation onto Linux boxes and those sorts of things. So I've used it a few times myself, but I'm definitely not an expert in that area. But if you're really interested in being able to do updates, so it's not the same as Pixie Boot, but it is kind of similar. So with, yeah, I've done Pixie Boot as well in the past, which also uses TFTP, I believe, but only with larger machines, not with little devices. Now, someone in the comment, yeah, a serious, Thromball said a can of squirrels, and Adam P said a seriously big can of squirrels. Yep. And Simon said, isn't the answer to this to switch to ESP? Probably. The thing is that there are different devices that solve problems in different ways, and they have different advantages. So for many devices, you can see those moments where my brain suddenly starts going, "True, I could go that way, that way, that way, or that way," and then I pause for a moment and I have to decide which train of thought am I going to follow. Am I going to chase the squirrel about choosing a board or an architecture for your project? Probably not right now. But there are certain situations where having a small 8-bit AVR with wired Ethernet is the right solution, or it's not necessarily right as in right and wrong, but it might be the optimal solution for your situation. And there are other times where using something like a 32-bit processor with Wi-Fi is the optimal solution to your situation. And they have pros and cons. With my personal preference, as I think pretty much everybody who watches this stream would know, is to is to use wires where possible. And I should clarify, I've had so many people over the years say, why do you hate Wi-Fi? I don't hate Wi-Fi, I love Wi-Fi. I use Wi-Fi a lot. But what I have an issue with is people with a very blinkered approach where they say, solve everything with Wi-Fi. And there are situations where Wi-Fi is absolutely 100% the correct answer to the question. And there are times where it's not. And if you have a situation where you can wire something for a little bit more additional upfront work versus using Wi-Fi for less upfront work, but potentially other issues like reliability or the thing is that a couple of wires carrying a signal is probably more reliable than a wireless signal. And I say probably because I put a big caveat on that. But most of the time, if you can pass electrons from one place to another, it is going to be more reliable than passing data through a wireless connection. It's just the way things work. So my preference in many situations is to hardwire Ethernet compared to using Wi-Fi. Wi-Fi is so much more convenient in many ways though. So depending on what it is that you're trying to do, if you've got a situation where you have a device that you need to update firmware on it remotely, then it is quite possible that using Wi-Fi is going to be better. And one of the reasons that it would be better is perhaps not what you would think. It is because of all of the work that has been done to create processes and technical infrastructure around over-the-air updates for Wi-Fi devices. Now the thing is that updating microcontrollers over wired Ethernet is not a very common thing. People just don't do it. Normally what happens is that if you are hardwiring a microcontroller into something, like into some kind of device, then updates to it are going to be extremely uncommon. And typically what you'll do is you'll plug into it in some way and flash new firmware onto it. It's the applications for that sort of thing are traditionally not a place where you're going to be pushing out frequent updates, so you want to deploy new features. And the whole thing about over-the-air updates has really been driven by mobile devices and devices that are deployed not just within one particular facility, but deployed across the world. It's when you have consumer devices that are being sold to many, many different people, and you have a large number of people who might have one or two of these devices each, or something like Wi-Fi light globes. It's a great example. You would never think of requiring a physical connection to a Wi-Fi light globe to do a firmware update. It's just totally impractical. That sort of thing you really need over-the-air updates. You need to be able to, as a product manufacturer, do things like add features, fix bugs, whatever it is you need to do, and deploy those updates to all those devices all over the world without any intervention by the end user. It has to be a totally hands-off process. So that sort of scenario with Wi-Fi connected devices, it is very, very common to do over-the-air updates. It's pretty much standard practice for anyone that makes devices that are consumer deployed with Wi-Fi. But devices that are hardwired into Ethernet, not so much. So that was a long-winded way of saying it, but basically, if you want to set up a mechanism to do software updates over a Wi-Fi to a microcontroller that has Wi-Fi, there is probably example code out there. In things like the ESP8266 or the ESP32, there is an OTA framework built into the ESP IDF, and it's also supported now in the Arduino IDE, and I use that myself. In fact, that yellow robot that you can see behind me, that's got an ESP32 in there in the controller, and I do my development on that using over-the-air updates. So I don't have a USB cable plugged into it. Usually what I do is I'll be sitting here at my computer. So I'm sitting here in the corner of the room, the robot is behind me, and I will do code updates and push over the air to the device behind me without plugging into it. And even over this distance it's convenient because I don't have to physically plug in. I mean, that thing moves. So if I had to have a USB cable it's way back over there. Way back over there. If I had to plug a USB cable into that controller and the robot was moving around, that would be a bit of a pain, and I'd need a really long USB cable. So I use over-the-air updates as I'm working on the firmware for that controller. And so the process of doing OTA updates to Wi-Fi devices is actually pretty well understood now, and there are frameworks that you can use to take care of that. Whereas if you're doing it via Ethernet, you have to do some, well, you need like a TFTP server on your network, which is not such a big deal. You can set up a TFTP server on a Raspberry Pi or on your desktop or whatever. That doesn't matter. It's not too hard. But there isn't really the easy infrastructure that allows you to do like the one-click, oh yeah, I've now recompiled my program, I want to deploy it to that robot, click a button, sit back and go, 20 seconds later, it's uploaded, the robot reboots, and now it's running a new firmware. And it isn't that smooth for a cabled Ethernet. Okay. Oh, YTFP Chris said, could really do with a wireless mic so you can run around the space and show us stuff. That's actually not such a problem. The problem right now is my camera. Oh, Nema, you've arrived. Hey, good to see you. I will scroll back and check a couple more of these comments in a moment, but yeah, I actually do have a wireless mic. Where is it? Right now, sitting on a shelf back over there with my camera gear. So I normally use a wireless mic when I'm recording videos, and I could just plug the receiver into my computer and be using the lapel mic rather than the desktop mic. But the problem is that right now I don't have a convenient way of taking a portable camera and moving it around. The camera that I'm using right now is my Panasonic G85, which is a digital camera, HDMI out going into the capture device, and it's all mounted on a tripod and fixed up over the computer monitor, so I can't just pick it up, and it's cabled, so I can't just pick it up and walk around. So one thing that I would really like to sort is some little portable camera, maybe I don't know, can something like a GoPro do wireless? If I could stream wirelessly and I had a handheld camera, I could walk around the lab and show you things. It'll be much more convenient. Jordan Reese said, what about a 32-bit processor on a wired connection? Well, cool, you can do that. I don't think a 32-bit processor on a wired connection, yes, you're talking about computers now. This is getting off the topic, but when I see things like this, I just think about the computers that I used to use as my full-size computers not very long ago, and they were slower than the microcontrollers that we play with. Oh well. Yes, a 32-bit microcontroller on a wired connection, something like an ESP32 on hardwired Ethernet, that is something that you can certainly do. But in fact, there are some that do it, like the WESP32, somewhere around. I have, I think over there somewhere, maybe. I won't make you wait while I look around for it now, but there are boards like the WESP32, which are very cool, and yeah, but it doesn't really solve the problem of infrastructure. And if any of you have ideas about this, I would love to know. So please drop stuff in the chat. And what I'm talking about with that is, so when I say infrastructure, I mean the device that you're updating needs some kind of bootloader that understands how to go out, connect to the network, find a new image, download it, and install it into itself, like write it into its own flash memory, and then reboot itself. So there is the bootloader as a component of it. There is wherever the image comes from. So you need some kind of a server that's going to host the new program that you want to install onto your device. And of course, this opens up all sorts of security issues. If you have devices that are pulling down new firmware and installing it onto themselves, they have to be able to trust that firmware, which means the firmware has to be digitally signed. So you need some kind of a crypto function. It needs to be able to validate that the update server that it's connecting to is the one that it's meant to connect to. What happens if someone does a DNS spoofing attack and redirects to a different update server which has a binary that has been Trojan, so it does some other function and it takes over your device. So your device goes out, looks for an update, connects to the fake server, and says, oh, there's an update, I better install that, downloads it, runs it on itself, and now your device has been compromised. So there are all of these sorts of things you have to think about as well. Solving the problem of making a basic system that works is not really hard. I mean, there's work involved in it, definitely, but you can make a proof of concept that will pull down a new binary and install it on your device, and you can make it work. But can you make it work securely? Can you make it work in a situation where someone is actively trying to attack your devices and fake out your update server and send you malicious programs? So there are all of those sorts of things. So if there are projects out there, please speak up. I'd really like to know. So a project that does something like provide an example implementation of the update server, of how to handle signatures and keys, and a reference implementation of the bootloader that pulls down from that server, and all of those sorts of things. So these are definitely non-trivial problems. Oh, Frank, I just saw a contribution from Frank. Thank you very much. That's really generous. Yeah, well, Stephen W. said the ESP32 is basically the same cost as a 328p while being vastly higher spec. That is correct, in some ways. Only in some ways. It's vastly higher spec in terms of processor speed. It's dual core. It's got a lot more RAM, and with a, it can have a lot more flash on it. But it is not vastly higher spec in a couple of ways. One is it pulls vastly more power. If you put an 18 Mega 328 on a board, it's going to pull only a few milliamps in operation compared to something like an ESP32, which can pull, like during boot up and while it's initializing Wi-Fi, it can pull 600 milliamps. So if you're making a device where you care about power consumption, an AVR is going to beat an ESP series chip every single time. They pull so much less power than an ESP. So that's one advantage of them. And also their I/O can be significantly better than an ESP32. Things like some examples. Well, the analog inputs on an ESP32 can be a little bit tricky. So yes, you can do analog in on ESP32, and I do it all the time. You can do it, but it has some complications to setting it up and getting it to work, and things like the input voltage range compared to something like an AVR, which has dead simple ADCs, so you can read from a bunch of inputs very easily. And there are a couple of other things as well. I can't remember what, but there are definite advantages to an AVR. And also, I don't want this to turn into a my processor is better than your processor sort of thing. And I don't want to give that impression. I'm not trying to say the AVR processors 8-bit are always the best. And hopefully people that have been watching my streams for a while or my videos for a while will know that my philosophy in relation to things like picking processors is that there is no one best processor, or there is no one best solution to any situation. Engineering is all about trade-offs. It's all about looking at what your objective is and what parameters you're trying to work within, and then come up with a solution that best fits that those requirements. And sometimes those requirements are nothing to do with the electrical side of things, or even sometimes the software side of things. A really major factor can just be familiarity. And this is why you see so many people who will they'll become really familiar with a particular type of processor or a particular architecture, and then they'll just use that in every project they do. And that can actually be a valid thing. So there might be a situation where you are working on a project, and if you were totally objective and you just looked at the tech specs, there is a particular processor that is ideally suited to that device or to that particular project. But it's a processor you've never used before, and there is a big learning curve in setting up the development environment and understanding the architecture of the processor and how to do software development for it. All of those barriers. And it might be that you are better off picking a processor that is not as well suited to it from an electrical point of view, but it's one that you are intimately familiar with, and it allows you to very quickly get a solution that works. And once again, there are caveats to caveats. If you are working on a device, or if you are working on a project where there are only going to be a small number of things created, say you're just doing something for you're building some custom solution and there are going to be 10 of them made, then a lot of the time you are better off using whatever tools are most familiar to you, because you're going to optimize your development time, and your development time is being amortized across a small number of devices. But if you are making a device that is going to be sold as a consumer device, maybe there are going to be 10 million of these particular devices produced. And if you can switch to a processor that is 5 cents cheaper, and there are going to be 10 million of these units produced, then the savings of that 5 cents per unit is probably worth your time to spend a few weeks learning about a new development environment, getting all of your software set up and all of that sort of thing, because it's going to be more than paid back by the savings of that 5 cents per unit once it's made in large quantities. So many trade-offs, so many decisions to make. Yes. So let me have a quick look at the chat. What have I missed? All right, so Amanda suggested use your phone with NDI HX for ISO and Droid OBS for Android devices. Will give you a wireless camera with next to no delay. Yeah, that's a really cool suggestion. I actually did this. Oh, it was a few months ago now. I wasn't using Droid OBS. That is a really good tip. I'm going to check that out. What I did was I installed an IP camera app on my phone, and then in OBS I connected to the RTSP stream from the phone, and I was using that. So this is when I was showing, it was a few months ago now, I did a live stream where I showed the pick and place machine running, and I had my phone sitting on a tripod running the IP camera software, and that was running back into OBS. But that did have a bit of lag in it. if Droid OBS doesn't have lag or minimal lag, that would be awesome. I'm going to check that out because I would really like to be able to grab a camera and walk around and show you things. That would be fun. So thanks for that suggestion. Now, okay. Oh yeah. So there are some comments earlier I missed. James O'Gorman said that's how 2U convert works, right? Yes. All right. So what this is throwing back to is my comments a little while ago about over-the-air updates and man-in-the-middle attacks. Man-in-the-middle attack is when you have a device. I'm going to do more hand waving now. Is when you have one device that you are wanting to attack, and you have another device that it connects to. So what you do is insert yourself into the network in the middle, and you pretend to be that remote device, and you respond as if you are that device. So the thing that you are trying to attack connects, and it talks to you, and it thinks it's talking to its proper server, but it's not, and then you respond to it. So that is how 2U convert works, is my understanding. I haven't looked into the source code of 2U convert, or specifically how it does its network connection. So 2U convert is a software solution to doing updates on devices that run the 2U firmware. Things like smart power plugs. And so the classic example is you go down to Bunnings and buy a smart power board or some light switch or whatever, which is running 2U, which is firmware that runs on ESP8286 processor, and you want to put Tasmoda on it. So what you do is you set up a fake update server. So 2U convert runs a fake update server. You power up your device. It connects and says, "Is there any new firmware?" And it can, your fake update device says, "Yes, I have new firmware for you. Here it is." And it gives it Tasmoda. So the device updates itself, and now it's got Tasmoda running on it instead of the original firmware. So there was a time, I think it was February last year, that 2U did an update that broke 2U convert, because 2U convert essentially is exploiting a security loophole in the update mechanism of the 2U firmware. And 2U did an update and they fixed that loophole, and 2U convert actually stopped working for a little while early last year, until the 2U convert developers found another security loophole and they switched to using that. So just a word of warning, if you use 2U convert, now I've used 2U convert myself. I've got devices around here running, in fact, in there is a smart light switch, which I'm going to show on a future video, and I've got some other things around the place. I've used 2U convert to install Tasmoda onto them, because it means you can do an installation without opening the target device. You don't need to solder any connections on, you don't need a jig. It's a totally software process. But what it's doing is exploiting that security loophole. So if you do want to use 2U convert, one word of warning: when you get your device and you bring it home, do not connect it to your network until you do the 2U convert process. Because what could potentially happen is you connect up the device and it connects out and looks to the real update server, pulls down a firmware update with a fixed firmware on it, which closes the security loophole, and then 2U convert won't work anymore. So if you're going to use 2U convert on a device that you've just gone and bought from a store, do that as the very first thing when you power it up. You have 2U convert ready to go, power up your device, and put Tasmoda on it. All right, so yeah, oh, interesting. So Stephen W. said, I replied to your tweet about the EtherUNO saying a low-profile Ethernet socket might be a good feature for shield compatibility, but they require a cutout in the PCB. Yes, I saw that reply to the tweet, and I went and looked at some suppliers of low-profile sockets, Now, I'm just wondering if I've got an example here. In fact, I think I do. Not too far away. Do I? No. Oh, there was a board over there that I thought might have had one of those low-profile sockets on it that I could wave in front of the camera. What about in this box? I've got stuff everywhere. No, not that I could find easily. But the major problem with things like this is the height of the RJ45 socket. It's it's bigger than the DC jack significantly. It's a few millimeters higher, and that is a real pain when you are putting a shield on it. So, where is an example of a shield? Somewhere I should have yes. Unfortunately, it means pulling down one of these boxes. Shields, there we go. So here, I'll find an example. Oh, and I have a real historic thing here. I'll pull out a couple of examples that I can stick in front of the camera in a moment. Oh, there's a horrible example. Okay. There's a variety of examples I'd forgotten about there. It shows how things have changed historically. So the problem with this board is clearance of a shield around this. Now there are no actual headers on this because it's just a prototype that I assembled. But what it means is that you end up with having to do things like this. So this is a shield which has a connection for an OLED and it's got a joystick input. So you could use this to make like a little user interface or a game or something on an Arduino. And that cutout, in fact I can plug it onto the ICSP header, and that cutout you can see fits around the RJ45 socket. Now with the height of the headers, the DC jack is not a problem. It just clears that. Shields typically sit pretty much on the top of the DC jack, and that gives us an upper boundary for how high we want anything to be on the Arduino board. So you can see there that the shield, I'll unplug it again, is that weird shape so that it can fit around the RJ45 socket. Oh, everything is backwards. There. And you can see here, this is a really old one. This is a couple of, in fact, what is this? Oh, this is a shield originally out of my home automation system, and this is the prototype of what became the Relay 8, which is the 8-channel relay driver shield. But this was before it was, so it wasn't using the MCP23017 addressable outputs. It was just using direct transistors. So you can see that, that's a bit out of focus. There's a row of transistors across here, and then there are resistors going down to digital outputs, and those transistors were switching relays. So at some point, this particular shield was switching relays inside the switchboard to control my house. And if you look on the bottom one, so it's two stacked together, and you can see that I've got, I was controlling some of these pins on this shield, and on this shield I was using these pins. So by stacking two together I just got more outputs. But look at this bottom one. It's got this hole cut out of it. I would have done this with a Dremel at the time just by cutting the PCB to make it fit. And where is my example? There we go. So once again, that was so that this would fit around the RJ45 socket. It would have been that, and then that on top of it. So this was before I had a Proto Shield. So I ended up doing the Proto Shield short which is a proto shield that is pulled down at this end so that it clears the RJ45 socket. And in fact, what I do on pretty much all of my shield designs now is use a profile like this. You can see that the end of it is slightly concave, so it comes up in order to give clearance for the reset button and the headers, and then it dips down a little bit on the end. So almost all shields that I've designed in probably the last 7 years, give or take, have an end on them that looks like that. And that avoids the whole problem. It just gives you plenty of clearance, and you can see that it fits around the back of the RJ45 socket like that. And that one does the same thing on a Ether Mega. Convex, not concave. That bit's concave. These bits are convex. So we can both claim we were right. I was thinking in terms of the bit on the middle. Yeah. Alright, so that was chasing a squirrel, explaining that whole thing. So once again, that was background to the whole thing about low profile RJ45 socket. So what we've got here is RJ45 socket is how high is it? 13.3 millimeters high, and the DC jack is 10.7 millimeters high. So if we could make the RJ45 socket low enough profile that it is at least as low as the DC jack, it would make things a whole lot easier, because we could just put regular shields over the top and not have to worry about clearance. Now, just as an aside, you can solve the clearance problem by putting an extra set of stacking headers in between, which just acts as a spacer and it moves the two boards further apart. But I don't like that. I mean, I've done it myself plenty of times, but it is pretty disgusting, because what it means is that you've got, it raises the board too much. You end up with a very high stack, but it can also lead to electrical problems. Stacking headers don't have square pins. They're flat. So stacking headers are made quite differently to regular pin headers. So these pins are like a square section pin on the regular pin header. The stacking headers are more like a stamped metal. So they are the same width this way, but they're very thin this way. And electrically they don't make a very good connection. Let's do a quick comparison. So a regular pin header is 0.6 of a millimeter thick, and a stacking header is 0.4 of a millimeter thick, which is a big difference. So the result is that when you take a stacking header and you plug it into a target board, so you've got something that you want to plug it into, it does plug in, but electrically it's a little bit dodgy. The little fingers that are inside the connectors on the socket don't bind so well to them. And I found that in the past, if I use stacking headers, and particularly if I use multiple sets of stacking headers, like one stacking header plugged into another stacking header, electrically they work most of the time, but you'll get failures a little bit more frequently than if you're using normal pin headers into a normal socket. So I try to avoid that. So back to the low profile RJ45 socket suggestion. What it is possible to do is cut out of this PCB so that there is a rectangular slot in the main circuit board, and then you can get RJ45 sockets that are designed for mid-board mounting, and it sits down into the middle of the PCB, and typically they have headers along the back, so they'll have pins that come out of the back of the socket and then go into your PCB, and they'll have mounting stakes sticking out from the side. So the result is that the entire RJ45 socket is moved down a little bit, probably about 1/3 of the way down, and that would make it fit Yeah, that would make it fit. So Joel said there's a mid-board Ethernet jack we've been using. It's only 8mm high above the board. It goes in a cutout in the board. It sticks out 2mm behind the board and slides in. Yeah, exactly. So I've looked around and I found a few suppliers, and I did think about it for a little while. I gave serious consideration to switching to a mid-board RJ45 socket, and I'm trying to think of a nice way of explaining why I didn't go for doing it. And I mean nice to myself. Basically, I decided it was too much effort. Yeah. I've looked at them. There are limited sources for them. There are some other complications. One is that because I want power over Ethernet support, ideally I want a jack that has got the built-in magnetics and the diodes, so that you can extract power off it without needing an external transformer. So what you can do is use a regular non-PoE RJ45 socket and then use external magnetics, which tend to be physically a little bit bulky. And I did look at some options for that. There were a couple of people that had some suggestions on Twitter. So I found a supplier, I think it was in Sweden, who had mid-mount RJ45 sockets with built-in PoE magnetics. And they looked like a really good solution. They're a little bit longer. They take up more board space than what I'm currently using, because the socket itself is about the same size, but then you have the pins coming out the back, which means that you need, I think it was about an extra 5 or 6mm of board space behind the RJ45 socket. And you also need extra space on the sides, because there are little supporting arm stakes that come out the side, and then they go down into mounting holes on the PCB, because you can no longer mechanically mount through the bottom of the PCB using stakes. Everything has to be mounted coming out the sides of the RJ45 socket. So electrical connections coming out the back, and physical mounting coming out the sides. So it was a situation where, yes, technically I could do it. I could move, at the moment I'm relying on space under the socket for tracks. I could move those elsewhere. I could put a cutout there, go for a mid-mount connection, and if I got this particular socket from the supplier in Sweden, I could make it work. It would cost more than the current situation, so these sockets are really surprisingly cheap. These particular hand run, so it's the HY931147C is the socket that's on it now. These are a super common socket, and they're made by many people. Handrun is the original designer of this particular socket, but you can get second source sockets from many different places. This particular design is built into a lot of products that use PoE, so they're really cheap. You can get these sockets, I can't remember the numbers, but it's like 50 cents for a socket with PoE support. That's pretty crazy. Whereas going for a mid-mount socket is more like $2 or $3 for the socket. So it was a difference. Oh, James suggested for EtherBear prototype with the mid-mount RJ45 fund. Oh, cool. Thanks, James. All right, so that actually is a prompt for where I was getting back to with this. And I am open to the idea of doing the EtherBear with a mid-mount socket. There are downsides to doing it. One of the things that I want to be able to do, now I'm going to unplug this just so that I've got some props that I can wave in front of you. Now, imagine that one of these is the EtherUNO and one is the EtherBear, and one of them, so they've got the two different chipsets, one's got more features than the other. One of my goals was to make them mechanically equivalent. If you design an enclosure for one of them, it should work on the other. It should be a direct drop-in replacement, and that's why the RJ45 sockets are in the same place, the USB-C socket is in the same place, everything is identical on them, apart from the chips that are used for USB serial and Ethernet. And so my preference is to keep them the same. But the whole idea of focusing the EtherUNO on being a drop-in compatible board and the EtherBear being the board with extra, so it's got the better processor and the better Ethernet chipset, means that there is already differentiation between them. So I am open to the idea of making the EtherBear more of a, well, distinguishing it more from the EtherUNO, and making it mechanically different is a possibility. So a mid-mount socket on that, and also because I've pushed back EtherBear development, would be yeah, I made that decision that once I conceptually forked those two designs, I want to complete the EtherUNO before I spend a whole lot of time working on the EtherBear, because otherwise I'll be fiddling with two parallel things and I just won't get to the finish line on either of them. I'd rather get to the finish line on one of them quickly and then get the other one to the finish line later, rather than delay them both. So my goal right now is to make that work. I want to make the EtherUNO work, get it into production, and once it's in production, I don't have to think about that anymore. I can put my mind more onto the EtherBear, and as I showed you earlier in Eagle, I still need to do all of the routing around the processor for that. There are some other changes I have to make. So I'm open to the idea with that one of switching to a mid-mount jack. But I also don't want that to be taking up brain space while Joel just said, side note, EtherBear is a safe Google search. Cool, thank you. I don't want things like the EtherBear features, like the IPv6 stuff and the custom Ethernet library. Now, I actually already did a custom Ethernet library earlier on in the process. I forked the official Arduino Ethernet library, and I took the updates, or the patches, the pull requests that were done by WizNet, and merged them. So I now have a version of the Ethernet library which is based on the official library, but with W6100 and IPv6 support. And I've got that up on my GitHub account now. You can install it and it works. It drives the W6100, everything works. But I don't want to, what I'm doing is putting all of that out of my mind and focusing on just getting the EtherUNO ready and going to production with it. Oh yeah, so Michael pointed out, spotted this the other day, might be a cheap WESP32 alternative. I've not tested this on AliExpress. LilyGo, TTGo, T-Internet PoE. That's interesting. Cinetech Geek said, what's a link to more info about EtherBear? Right now there isn't a whole lot of info other than on GitHub, and let's see if I can find that. EtherBear, so there's a repo. The thing is that this is, because the EtherBear is really a fork from the whole Ether10/EtherUNO development process, it's, and I'll drop a link in here. So this is the design files for the EtherBear. I'm not even sure if I've pushed recently, so when was it? Pushed? Yeah, I pushed 13 days ago on that. But I'm going to largely ignore this until the EtherUNO is out there and in production. So, yeah, Stephen said being mechanically different is a bonus. Oh, sorry, being mechanically identical is a bonus. Yes, that is a factor. but like everything, it's all about trade-offs, and if there is enough of a benefit to going with a mid-mount jack for the EtherBear, then yeah, I'm quite open to that idea. So I'm going to investigate that. What I'll do is I'll probably order some of the mid-mount jacks, because when I'm doing this sort of prototyping, I really like to have the physical device here with me. Using datasheets is good, but as Andrew from the local hackerspace says, if you don't measure, you don't know. And that's why I can always reach across, and calipers are right here. I've got into the habit of measuring everything and verifying everything, doing paper versions, so printing out circuit boards and then physically putting parts on them to make sure that they fit. And several times that has caught problems before I've gone to production with a PCB, and I've discovered that I had offset slightly wrong on pads or something was not quite right. Pancake legend, to measure is to know, yes. So yeah, I must have misheard at some point when you said that, Pancake. I thought you said if you don't measure, you don't know, but to measure is to know is more concise. I like that. All right. So Simon's asked, is EtherUNO working with MQTT? Are the limitations as I'm currently forced to use ESP8266? Yeah, very good question. Yes, it does work with MQTT. There is an Arduino library called the PubSub library by Nick O'Leary, I think, is the developer. And I'm using, short answer is yes, as an MQTT client, not as a broker. If you want to, something like an 8-bit AVR, it's really just not practical to implement a broker in that, but you can definitely implement it as an MQTT client. And so that's actually one of the original design objectives of MQTT, was to make it a protocol that could be implemented in a very lightweight way in small processes. So so Adam P said the PubSub MQTT is great, but it seems to gag on longer messages, at least on the ESP8266. Yes, I could chase a whole squirrel on that one. That is a problem that bit me on the air quality sensor, but you can fix it. There is a way around it. It's not at all obvious. And digging into it, if you search on how to solve that, all you'll find is people with wrong solutions or saying it can't be solved. It can be done, and it took me some digging. I need to talk about that one in the future, I think. In fact, I know that one is going to be covered in the Air Quality Sensor Pro episode. I'm using an ESP32 on that, and I wanted to be able to publish large chunks of JSON to MQTT. And when I was publishing a whole bunch of different parameters, I ran out of space. There is limitations in the buffer in the PubSub client library that I can't remember what it is. I think it might be like 128 characters. It's somewhere in that region. And the way Tasmota gets around this is it actually embeds the PubSub client library directly into the Tasmota source code, and they've got a hacked version of the library that allows a much bigger buffer. And anyway, after much digging around, I figured out a way to use the unchanged PubSub client library and pass a parameter to it that increases the buffer size, and then you can send larger messages like big chunks of JSON. But for an MQTT client, you can definitely do that on something like an Ether 10, and that is what's running my house. Like all the lights in my house are controlled by a switchboard, which is controlled by an 8-bit AVR running an MQTT client connecting to my broker, and my home automation system publishes to MQTT, which then causes the microcontroller in the switchboard to turn devices on and off. So hopefully I won't annoy too many people here. If you've got an Alexa, hit mute now. Oh, I said it. Sorry. So if I say, Alexa, please turn off the office lights. That was all done through MQTT using an AVR. So it's actually an ATmega 328. It's an Ether 10 sitting in or mounted in a plastic enclosure just below the switchboard, and it's connected to my broker, and it's controlling the relays and the switchboard. The lighting on that actually looks kind of cool. I'll leave those lights off. Where is all this light coming from? I think it's just coming from my screens. I don't have any other lights turned on here. Somehow the camera is managing to deal with it pretty well. There's a skylight behind me as well. Amazingly, I am almost out of time. So, let's see. Any last minute squirrels that I can chase? So, oh yeah, so Stephen said the EtherBear can be positioned as a premium alternative to the EtherUNO. More RAM, more program space, and more features. The bill of material cost being higher is absorbed by a more acceptable higher sale price. Yeah. Yeah, the way I see it, that's a good way of putting it. The way I see it is not so much more a premium product. I think the distinction is more out of the box easy versus experienced user more capable. And I need to figure out a better way of articulating that. So it's more about the ease of use versus the extra features. So maybe people who can help me with how I do the messaging on that. ESP Flasher ready for sale. Ah, yes, I was going to talk about this. Okay, so Cable Tie just said, I'm in darkness. Did I just turn off your lights? I wonder. All right, so I'll see at the buffer limit. Okay, on the cat flap controller. Okay, so a few people have had problems with that, with the MQTT client buffer. It sounds like that is definitely something that's worth talking about. How much time do I have? I've got a few minutes. Let's see if I've got, if I can easily pull up an example. And there are a couple of other things here that I want to mention. The ESP Flasher, I will get back to that. That is important. But first, I am just going to see if I can find my source code with how, oh, come on. I clicked on the file menu and I'm waiting for it to open. The menu hasn't even opened. So let me see, open. Where is the firmware for the air quality sensor? I've got to dig down through my projects directory, and that'll be I can't talk and do something else at the same time. My brain just doesn't work that way. So while I'm navigating down through directories, I have a lot of trouble. Where are we? AQS, air quality sensor firmware, getting closer. And open. And then I'll throw you to my desktop so you can see what I'm looking at. Well, it's just opening the file at the moment. All right. While Arduino IDE is opening, I will just mention the ESP Flasher situation. I had something here to show you. Where did it go? Where did it go? Ah, here it is. All right. In fact, I'm going to throw it back to the overhead camera because it might be easier for you to see what is going on. Where are we? Here. Okay. So, this is the ESP Flasher, and I now have a bunch of these assembled, ready to sell. So, may be even today. It is like really that close. I will make this live on the site. The thing is that there needs to be some extra documentation to go with it. There's not a whole lot of point making these available if I don't also have a nice guide that goes with it that shows all of the pinouts and everything else. But this is done. I'm using these now on my own projects and on customer projects, and it works brilliantly. Now, the big thing this week is that this is the ESP flasher adapter. So it's a little octopus board. All it is all the different pinouts of the ESP flash header format all linked together on a carrier board so that you can cater to everything. So with the ESP flasher on its own, you can plug that straight in on the 1x6 0.1 inch header and it works. That's fine. Or you can plug it into the adapter like that, and now you've got the 1x6 in the 0.05 inch format. You've got the 2x3 in 0.1 inch and 2x3 in 0.05 inch. So this gives you all possible combinations of connectors on the target board. So you just plug USB-C into here, and then you've got 4 different output formats. Now, the thing that happened this week was on Friday, these headers arrived, and it only took 75 days in transit for them to arrive from China. So, thanks COVID. But now I have the 1.27mm pitch right angle pin headers, and I've now assembled a bunch of these, so I've got the flasher adapters ready to go as well. Now the cool thing with this is that you can use an IDC cable. So this is the same cable you would use on an ICSP programmer, like to an Arduino, and your target board can have an ICSP, not ICSP, it's the same cable. It can have that same shrouded header on it, and this is what I've done on a board for a client. It's actually for a robotics project. It's not for the water cannon project that you can see behind me there. It's for another one that I'm not talking about because it's a commercial project that I'm not going to disclose at this moment, but it's big. Really, really big robot. Definitely the biggest thing I've ever worked on, like physically. And what I did on the controller for that project is I put the 2x3 shrouded header on the target board so I can plug this into it. And in some situations this is nice. Being able to have a target board that's on the end of an IDC cable means that you don't have your programmer and your USB cable going all the way to the target board and potentially being pulled around by it. It's just more stable. So having this sort of connection plugged into the target board is more convenient in many situations. So for that particular robotics project, the controller has a 2x3 socket on it, and I just plug the programmer in and then I can reflash it from there. So yeah, the big news is that these are all done, and I've used them on projects myself, both personal projects and client projects, and they work brilliantly. So I'm happy with them for my own use and ready to release them, but I need to do all the documentation that goes around it. Alright, so let's have a quick look at this MQTT buffer issue before I totally run out of space. Now, originally I had a version of the PubSub client library directly within this, and I've got to find where... Okay, so you can see message buffer. Yeah. You can see here I've defined MQTT message buffer and I've made it 150 characters long. Now I've got to remember how this was done, because somewhere there is an argument that you can pass, or is it a config? It's a little while since I've looked at this code. Alright, so where is MQTT doing its thing? Where is it setting first thing is we're setting up the client using ASP client because it's on Wi-Fi, and somewhere I have a feeling that it might be like a compile time argument. This is what happens when I'm answering questions on the fly and it's not I'm not prepared. I've got to go through and dig into it. Okay, this is interesting. This is really illustrating exactly the problem that we're talking about. So what you can see here is two different messages that are being defined, and there is there is a version there. You can see that there is this MQTT message buffer that is being filled with this chunk of JSON using sprintf, and it's taking all of these parameters. Now compare that to this one here, and this is replacing, so what it does is up here the message buffer is being filled, and then down here the exact same message buffer is just being replaced, but it's being replaced with a shorter message because the number of parameters here, you can see there are 9 parameters in this, so 3 lines here with 3 parameters each, and up here there are 12 parameters. There are 4 lines with 3 parameters each, and this message would not fit in the MQTT client buffer. Well, it would fit in the buffer, but then the client itself couldn't send it because of that, I think it's 128 byte limit. And this message would fit in the buffer. So you can see here that my temporary hack was to, this is what I wanted to send, and instead I'm sending this, and I'm compromising by not sending all of the values. Now, where was the setting? I'm just going to move this off screen for a moment. Oh, that is not what I wanted to do. Give me back control of the window, please, because I'm going to have a quick look in here. Oh good, it's safe. Where is it? I think it must have been in a different version of the code that I fixed it, because it's not in here. So I've got no yeah, I'm sorry. I was hoping that I was going to be able to pull this example up and just show you where I fixed it, but I don't think it's this one. Somewhere I've got, and it'll take me a while to find it, so I'm not going to make you sit there and watch while I go digging through things. Adam, I'm sorry. Adam says no. Alright, let's try. I will have one little attempt at trying to find this. So maybe there is somewhere else that is fairly obvious. Oh, come on. Okay. Open, what have I got? No. Let's see what I can find. So it's not in there. I thought that was the project that it was in, but it looks like it may not be. So there must be some other firmware somewhere else where I did fix that problem. Maybe it is within my sketchbook and not, oh, let's see. Air quality sensor. Ooh, this could be hopeful. And PM25 sensor combined. I've got so many different versions of this firmware. Alright, it's opening the sketch. Probably a quicker way to do this would be to grep around in the directory, see what I can find. Somewhere. Oh, this is looking hopeful. Look at this. MQTT message buffer 255. So I think this might be the version of the firmware where I fix that problem, and then I need to pull it across. So Adam, all is not lost. We might have an answer for you here somewhere. So pub/sub client is defined in just the same way. Somewhere, hang on, I'm going to pull this off screen again so you can't see it, because I don't know if my Wi-Fi thing is set in there. No, it's not. In so many of my sketches I've got my Wi-Fi details in here, and if I inadvertently open it on a live stream, you'll all see yeah, and here MQTT username and MQTT password. You could see it, so I need to open it while it's not visible on screen. And where is the... it'll be in the connect thing, I think. Oh, here we go, set buffer size. There it is. Adam, we've solved the problem. So we've got client.set server. So we set the connection to the broker and set the callback. So we've got an MQTT callback function, and then it's got client.set buffer size 255. And that's a magic number. That's a code smell. What I really should do is replace that with say something like MQTT buffer size, and define, and then back up here. I should stick that in there, and I should define that in here and say MQTT buffer size. You know where I'm going with this. I should do that. That would be much nicer. Have it all defined in one place. Dodgy says, show your username and password. We promise not to hack you. Yeah, right. And yes, I know you would have to drive and sit outside my house, but there are people that know where I live. So, getting back to this, where is it? I've got to find that thing again. All right, this is the magic thing. Client.set buffer size. Now this was implemented, I think, not that long ago in the pub/sub client library. So the even as recently as like a year ago, there were people asking on where was it, the forums or wherever, about changing that buffer size, and the author of the pub/sub client library, which I think is Nick O'Leary, if my memory is correct. Yeah, he said, sorry, we don't have any option for that at the moment. But then more recently, it seems to have been implemented. So, yeah. Yeah. Oh, Andy just put in the link to the pub/sub client library. Thank you very much. Cool. Thanks, Andy. Now, I am well over time, but I'm just going to have a quick look. Andy has just highlighted a couple of things that I should have a look at. So Joel Plunkett asked, any luck with quality PowerPoints for automation yet? I'm going to leave this on screen just for anyone that is taking notes. So quality PowerPoints for automation, not yet, but I'm hopeful. I've actually just received a smart PowerPoint. So it's a GPO with 2 sockets, touch switches. It's got an ESP8266 in it. Actually, I think it might be an 8285. It's a 2-year module, and it does power monitoring. It's still in the box. I haven't taken it out because I want to experiment with that and see if that is a valid candidate for smart PowerPoints around the house. So the short answer to that is that I have one that I'm about to play with, but I can't actually answer yet whether it's any good. And Simon Wren said, do you have EtherMega available, as I need some for pins available and memory required? Yes, I do have EtherMegas at the moment. I don't know about stock on the Superhouse online store for EtherMega. I think there are some, but there are definitely some in stock on the Freetronics online store. So you can order those now. All right. Yeah, Adam, cool. I'm really glad I could help you with that. This is something that I bashed my head against for quite a while, and it's a very annoying problem when you're trying to publish to MQTT. And the thing is that for me, this was failing silently originally, and I couldn't figure out what was going on. I had, I butted into this problem, as I said, with the air quality sensor project, and everything was working beautifully, and I was reporting different values back to the MQTT broker, and at some point I added, it was when I did the Pro version, that's right, and I added the BME 680 so I could do volatile organic compound detection and some other parameters, and I was reading the values from it, I was getting the values, and I added them into the JSON, and all of a sudden everything stopped working, like I was getting no reports. And I thought I'd broken something. And it took me a significant period of time to figure out that it was the length of the message that was exceeding the message buffer. And that's why it just wasn't reporting to MQTT. And I took a parameter out and it started working, and I put it back in and it stopped working. And I thought there was something wrong with the parameter that I was passing it. I thought I had a type issue, like maybe I was passing it and int when I needed to pass it a string, or one of those sorts of classic C problems. And I went down a few dead ends there trying to solve it until I realized, no, it's just the size of the message. So hopefully that makes it all work better for you. So alrighty, I am going to call it a day today. Thank you very much for hanging out with me on a Sunday. Just looking up at the monitor now, I can see that it stopped raining, but it has barely stopped raining here for days. There is just like deep standing water puddles everywhere around the place. Can't go out onto the back lawn because it's just a swamp. But being here, having a chat to you, it makes it all worthwhile. Thank you very much for coming along on a Sunday, and thank you also to the people that contributed on those super chats. I really appreciate that. And when I get to the baby bear development, I will look at those mid-mount RJ45 sockets, because they do make it easier if you want to stick a shield on top. I totally understand that problem. Yeah. Joel said, has the auto mower become a boat? It's actually turned off right now because it just chews up the ground. It's so muddy in my backyard. Yeah, an amphibious mower. All right. I hope you all have a fantastic week this week. And next week might be a special week. I might have a guest on. If I am going to have the guest on, then I will announce it a few days in advance, because you will probably have questions for this particular person. I will confirm it before I tell you who it is, because I don't want you to get you excited and then disappoint you. So I'm going to sign off, go and get some lunch, have a great Sunday afternoon or Sunday morning or Saturday night, whatever it is, and I will see you next week, either alone or with a guest. Now go and build something awesome.